Hello students, the topic of this session is De Morgan's theorem. In this session, under De Morgan's theorem, we have two theorems. First one says that the complement of a sum equals the product of the complements. Complement of a two sum variables. Here this is the formula to complement this theory. The complement of a sum, the whole complement of a sum, the whole complement of this sum x plus y is equal to the product of the individual complements. This is the product of the individual complement. The result of this should be equal to result of this one. That is the concept here. To prove this, we have a table with inputs 0, 0, 0, 1, 1, 0 and 1, 1. If I apply the OR operator to this set of variables according to OR table, see here I have a OR table. If I apply the same logic here, I can fill it as 0 plus 0, that is 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. Complement of this result will be filled in this section. Complement means you need to take the opposite values of these things. Here, if you have 1 as input, that means you need to write the 0 as output. If you have 0 as input, you need to write the 1 as output. It's a complement operation. Here, from ORing these two variables, I have got 0 plus 0, 0 logical OR, 0, the result is 0. So complement of 0 is 1, complement of 1 is 0, complement of 1 is 0, complement of 1 is 0. Next, I have two other variables here. X complement. You need to complement the values of only this column. That means if there is a 0, you need to write 1. If there is a 0, you need to write 1. If there is 1, you need to write 0. Since there is 1, I am writing 0. Now y complement. That means you need to take the opposite value of this column. That is y column. Since there is 0 here, I am writing 1. Since there is 1 here, I am writing 0. Since there is 0 here, I am writing the bit or binary number 1. Since there is 1 here, I am writing 0. You need to apply logical AND to these two variables, x bar and y bar. That is what this operation is telling. This dot operator is indicating we need to apply logical AND operation. So, what does the logical AND table tells us? According to this, as we have already discussed, 0 into 0. If any one of the input is 0, the output is 0, according to AND logic. If both the inputs are 1, the output is 1. Since both the inputs are 1, output is 1. Next, if any one of the input is 0, output is 0. 0. Any one of the input is 0, output is 0. Obviously, one of the input is 0. This is 0. We need to prove that x plus y, the whole complement, is equal to the individual complements of x and y. So, here we need to compare x plus y bar and x bar, y bar. Both the columns are being matched. We have same set of values in both the columns. Hence, x plus y bar equal to x bar into y bar. Idu prove aitu. Coming to theorem 2, the complement of a product. See here, this is the product. Complement of the product equals the sum of the complements. Equals sum of these two individual complements. Now I am going to prove this. To prove this, again I have taken the same set of values 0, 0, 0, 1, 1, 0, 1, 1. If I apply the logical AND here, according to logical AND table, if any one of the input is 0, output is 0. 0, 0, logical AND 1, 0, any one of the input is 0, 0. Here no input is 0, output is 1. Complement of this column. The whole complement of this column is, since there is a 0 here, I am writing 1, 1, 1. Since there is 1 here, I am writing 0. Opposite of that value. Remember, you need to write only two binary values, either 0 or 1. Now, again I am moving on to individual complements of these variables. If there is 0, consider only this column. 0 ide 1 ತಗೊಳ್ತೀನಿ, 0 ಇದೆ 1 ತಗೊಳ್ತೀನಿ, 1 ಇದೆ 0 ತಗೊಳ್ತೀನಿ, 1 ಇದೆ 0 ತಗೊಳ್ತೀನಿ. Y complement. 0 ಇದೆ, consider this column, 1 ತಗೊಳ್ತೀನಿ, 1 ಇದೆ 0, 0 ಇದೆ 1, 1 ಇದೆ 0. X bar plus y bar. Apply logical OR operation. Logical OR operation to these two columns. Remember the logic of OR gate, that is this one. If any one of the input is true, the output is true. Apply the same logic here. If any one of the input is true, since both the inputs are true, the output is true. True means 1. 0 means false. If any one of the input is true or 1, output is 1. If any one of the input is 1 or true, output is 1. Illi, in both the columns, we do not have 1. 1 ilde iradrinda 1 column allu 1 illa. So, according to logical OR operation, output is 0. So we need to prove that x into y, the whole bar equal to individual complements. Whole complement equal to individual complements of R. So we need to consider x into y bar column, this column, and x bar plus y bar column. We have the matching results here. Hence, this theorem is proved. The complement of a product equals the sum of the individual complements. According to theorem 1, the complement of a sum equals the product of the individual complements. So, these two are the DeMorgan's laws. You need to write the theorem and prove using the truth table. Thank you all.